Hi everyone. So in this video we are going to discuss about a concept called pipelining. This pipelining is a concept which is majorly discussed under computer architecture or in computer organization, right? So the meaning of this pipelining is whenever an instruction is executed in a processor or in a microcontroller, the instruction has to pass on different kind of stages like fetch, decode, execute, memory read and write back or memory read, right? So the instruction has to pass these 5 kind of stages, right? If an instruction passes this 5 stages, then it is known as pipelining, or the instruction has to pass this 5 stages, right? Then it is known as pipelining. There are 2 different kind of pipelining. The first kind of pipelining is 3 stage pipelining. The second stage of pipelining is 5 stage pipelining, right? So 3 stage pipelining is nothing but it will stop in first 3 stages. I mean fetch, decode, execute. These 3 stages will come under 3 stage pipelining, and fetch, decode, execute as well as memory write back or memory write back is known as 5 stage pipelining. 5 stages of pipelining, right? So we already know that an instruction is executed only when it is error free, right? With the help of mnemonics and operands, right? So let us assume a scenario that a processor or a microcontroller executes different kind of arithmetic and logical operations, or it executes different kind of tasks, it performs different kind of tasks, right? These multiple tasks as well as arithmetic and logical operations are performed by instructions, performed by different kind of instructions, arithmetic and logical instructions and branching instructions. These instructions need to be executed in a faster manner, right? So it need to be executed in very fast, right? That is the ultimate aim of a customer, right? Or a user, right? So for executing an instruction in a very fast manner, we prefer pipelining. That is the main objective of pipelining, right? So how this pipelining is performed, right? Or how it is performed in instruction. How this concept is performed in instruction? Let's see that now, right? So first stage of pipelining is fetch, and the second stage is decode, execute, memory read, memory write back, right? So first stage is fetch. Fetch means the processor fetches the instruction from the instruction memory, right? So we will store the instruction in the instruction memory. So it will fetch the instruction from the instruction memory. It will fetch the one by one instruction from the instruction memory is known as fetch. This is the first stage. And the second stage is decode. Decode means the fetched instruction from the instruction memory is decoded from one language to another language, right? So human level language to machine language, right? That is the decode stage. And the third stage is execution stage. The particular operation of that instruction will be done in this stage. That is the execution stage. And the fourth stage is memory read, right? If the memory read or branching instructions will be performed on this memory read, right? And the fifth stage is memory write or write back, right? Some data will be stored in the memory. We need to write some data in the memory, right? That will be performed in this fifth stage. Now let's see this corresponding stages in a graphical manner, right? This instruction 1, instruction 2, instruction 3, instruction 4 and instruction 5. So let me take this 3 stage pipelining as an example, right? Let me assume fetch, decode, execute stages alone for this graphical representation of pipeline, right? So T1, T2, T3, T4, T5. So these are the clock signals and clock signal, and this one is instructions. So I have taken 5 instructions, I1, I2, I3, I4 and I5, and T1, T2, T3, T4, T5 are the clock pulse, right? So clock pulse 1, clock pulse 2, CLK 3, T4, clock pulse 5, right? So instruction and clock pulse, right? Now the first stage, so instruction 1, right? Every instruction, as I already told, every instruction has to come across all the stages, right? Fetch, decode, execute, right? So fetch, decode, execute, fetch, decode, execute, fetch, decode and execute, right? So this is the corresponding pipelining graphical table, right? So here I have taken T1, T2, T3, T4, T5 as clock pulses stages, and I1 instructions, I1, I2, I3, I4 and I5 in this, right? So in y-axis I have taken instructions, and in x-axis I have taken clock pulses, right? So T1 is clock pulse 1, T2 clock pulse 2, 3, 4 and 5, followed 5. Now look at here. So instruction 1 has to pass this, all the instruction has to pass these stages, I mean fetch, decode, execute. Now instruction 1 at T1 it fetches, and T2 it decodes, and T3, I mean clock pulse 3 it executes, right? Similarly, now look at here. When I1 instruction 1 fetches in T1, I2 and I3 are not processed, right? Instruction 2 and 3 are not processed. When instruction 1 is decoded at clock pulse 2, simultaneously instruction 2 is fetched, right? During clock pulse 2, right? Next, while instruction 1 is executed at clock pulse 3, the instruction 2 is decoded in clock pulse 3, as well as simultaneously, parallelly, the instruction 3 is started to fetch, right? So similarly, this process will keep on moving forward until all the instructions are executed, right? So this is known as pipelining, right? So when a particular instruction executes simultaneously, its consecutive instructions will be processed under the